Hi everyone. This will be the third lesson on how to add and subtract rational expressions with unlike denominators or non-common denominators. So notice that the LCD must include all factors from the original denominators. So factor denominator first. Okay, so for example, if you look at this when you saw this for the first time, the LCD in this case, sometimes this works, sometimes it doesn't, but if it works, then try it out. So the LCD in this case you get by multiplying 3 times 2, which means that the LCD is equal to 6. So that tells you that you must multiply 1 over 3 by 2 over 2. Okay, and then this one you multiply by 3 over 3. So once you do that, you end up with, so this is 1 times 2, that gives you a 2, and 3 times 2 gives you a 6. Plus 1 times 3, that's 3, and 2 times 3 is 6. So as you can see, we have the same denominator. So once you have the same denominator, then you just add the numerators. So then 2 plus 3 gives you a 5, and then 5 over 6 is not simplified because 5 is prime, so they have no factors in common. This is as simple as we can get with this fraction. So we are going to use the same idea with algebraic rational expressions. So first notice that this problem here, this has an x minus 3, this is an x minus 2. So they do not have the same denominator. So what we do is we multiply this one here by what this one has in the denominator, and this one gets multiplied by what this one has in the denominator. So this is what I'm saying. I'm going to multiply by x minus 2, because that's what this one doesn't have. So over x minus 2. And then do the same thing here. This is x minus 3, then multiply this one by x minus 3. Numerator and denominator. So again, we're just using the how come number 1 is very powerful. You can write it in any way you need to so that you're able to work the math problem, or in this case the algebra problem. Okay, so then I'm multiplying here, I'm distributing 3 times x, that gives me 3x, and then 3 times negative 2, that's a minus 6, and then the denominator, I'm going to leave this in let's see, I'm going to multiply this one here, but I'll just leave it in factor form. So we have x minus 3 times x minus 2. And then this is plus 2 times x, that gives us a 2x. And 2 times negative 3, that's a minus 6, all over x minus 3 times x minus 2. Okay? And from here, since we have the same denominator, we just combine like terms. So then I have 3x plus 2x in the numerator. We have a combination of 5x when it comes to the x's, and negative 6 and negative 6 combined to negative 12. All of this over x minus 3 times x minus 2. Since we have variables in the denominator, well, only x, right? Only one variable. So then let's restrict the values of x, which means x cannot be equal to, for this one, positive 3, and for this one, positive 2. So this is the answer to the sum of these two rational expressions along with the restrictions. Okay, so let's move on to the next example. This one is not in factor form, so let's factor it out. Okay, so that's what I mean by this. If you have something that looks like a quadratic, then you factor it out first, so you can see what this one needs to be multiplied by. So this is a difference of squares, which means we have x minus 4 times x plus 4. So now we can see that this one has the x plus 4 but doesn't have the x minus 4. So that tells us that we can multiply this one by the x minus 4. So that is what I'm going to do next. So x minus 4 over x minus 4. So for this one here, we can factor out a GCF. Well, we don't have to. We'll just leave it as 2x minus 8 for now, and then we'll combine like terms and see if we can simplify something here. So then this leave us 2x minus 8, and denominator is it's x minus 4 times x plus 4. So now we have plus, we're multiplying, distributing 3 times 3 to the x, that becomes 3x. And 3 times negative 4, that's minus 12. Now this again has the same denominator as this one because we just multiplied by x minus 4. So we have x minus 4 times x plus 4. Since we have the same denominator, what we can do is we can combine like terms in the numerators. So 2x plus 3x combined to 5x, negative 8 and negative 12 combined to minus 20 or negative 20. And then denominator, we have x minus 4 times x plus 4. Okay, so in this case, as you can see, we can factor out of 5. So then this is 5 as a GCF, and this becomes x minus 4. All of this over x minus 4 times x plus 4. But now we can see that this x minus 4 and this x minus 4 reduced to 1. So then we have 5 times 1, which is 5, and we have only x plus 4 in the denominator. But again, we're not done because we must state the restrictions. So we have minus 4 and plus 4, which means x cannot be equal to plus or minus 4. So here we have the answer. This is the answer to this problem, and these are the restrictions. And we are done with this problem. Okay. All right. I hope you're getting this, so that when you do the assignment in class, you're not having any challenge or not as much of a challenge with this. So what's going to be important here is the factoring part. So again, look at this example. This one has x plus 4 in the denominator. This one is a quadratic trinomial. So then we need to factor this one out first. So what we need to find is we need to find the multiples of 12, that when we add those multiples, they give us a 7. So those are 3 times 4. So x plus 4 times x plus 3. So now we can see that this problem is missing, this expression is missing the x plus 3, because it does have the x plus 4. So then let's multiply numerator and denominator by x plus 3. All right, so then we have distributing 7 times x, that's 7x, 7 times 3, that's 21. And then now we have this over x plus 4 times x plus 3. Because of this, we distribute it and multiply the bottom by x plus 3. So then this one is 7 over x plus 4 times x plus 3. Okay, now since we have the same denominator, let's combine the numerators, or the terms in the numerator. So 7x, we just leave 7x, and then 21 plus 7 is 28 over x plus 4 times x plus 3. So then there's a GCF between 7 and 28. So let's factor it out. So let's factor out 7, and then this becomes 7 times x plus 28 divided by 7 is 4. So then we have 7 times x plus 4 over x plus 4 times x plus 3. And this is why we leave the denominator in factor form, because then we can see what's going to simplify. So x plus 4 and x plus 4, we can cross them out. So then in the end, this simplifies to 7 over x plus 3. But again, don't forget, the last thing we need to do is restrict the domain, the values of x, because we cannot allow the denominator to become 0, because division by 0 is undefined, right? So then x cannot be equal to, for plus 4, minus 4, and for plus 3, minus 3. So these are the restrictions for this rational expression. Okay, and that's all for this lesson. Thank you for watching. I'll see you in the classroom. Bye-bye.